let's talk about a different machine learning algorithm called hierarchical agglomerative clustering. And I like it because it shows you what a huge difference the choice of algorithm can make in machine learning. Okay, it's a very, very simple clustering algorithm. You just start with each data point in its own cluster and repeatedly merge the clusters of the two closest points. So if this is your data set, you just start with each point in its own cluster and then merge the clusters together, based on which points are really, really close to each other. Okay, so you just keep doing that until it's fully connected, or else you can stop earlier to get different numbers of clusters. Okay, cool. So let us try it on the Jelly Roll data set. Okay, remember, k-means was awful on this data set. K-means produced garbage on this data. So let's try hierarchical agglomerative clustering, and we'll stop it just before the very end, and perfect. A lovely result from hierarchical agglomerative clustering. Now let's try it on this data set. And that's the result. It put almost all the points into one cluster and put the outliers into their own clusters. Okay, not so good. What if we stop it a little earlier? So this is the result. It's not brilliant. It merged some of the clusters so fast that we couldn't really stop it. Okay, so it's far from perfect. This algorithm is just really not meant for these kind of spherical overlapping clusters. It does much better with these like long, twisty, manifoldy clusters. So anyway, it's kind of neat. Like k-means thought this one was easy peasy. So it just goes to show you that the choice of algorithms and the match of the algorithm to the data set, that can really make a huge difference. Now, hierarchical agglomerative clustering produces these dendrograms that can tell you what clusters are being merged. Okay, so they list all the data points at the bottom and they tell you which data points are being merged to which other ones and which clusters are being merged to which other ones. And then you can cut it off at any point. So here we stopped at 7 clusters, and then you can see the data points that were assigned to each of the clusters. Or you could cut it off at 2 clusters like we did, for example, with the Jelly Roll data. Okay, so just to summarize, I showed you 2 clustering methods, k-means and hierarchical agglomerative clustering. They're useful for different sorts of problems. K-means works well for spherical data, whereas hierarchical agglomerative clustering is useful when clusters are well separated. And so here, for hierarchical agglomerative clustering, 2 points that are close together, they're gonna essentially be in the same cluster because they're gonna get merged first. Okay, and there are different linkage criteria for hierarchical agglomerative clustering. I was only using one of the criteria, which is just the min criteria, but you can, you can choose a different criteria that determines when these linkages between clusters are actually made. And I would recommend kind of experimenting with the different linkage criteria to get different results. And it really will give you different results if you use different linkage criteria. So that's something that's really nifty. Okay, and then for k-means, one needs to choose the number of clusters where, as I mentioned, you iterate over k and then you choose the point of diminishing returns. Whereas for hierarchical agglomerative clustering, you just choose when to stop merging clusters, and then you also choose the linkage criteria. So those are the 2 choices you make in that algorithm. Now, I've been using Euclidean distance so far, but you can, as I mentioned, use a different distance metric. And that distance metric, that choice is actually really important, and it can really have a large impact on the solution. So you really want to choose a distance metric that kind of is sort of natural for the problem that you're actually working on. Okay, so I hope you enjoyed this lecture on clustering algorithms.